Okay, so may apat pa, pero apat pa lang. We're going to start. I'm going to discuss slowly this chapter 4, section 3 uh, topic. By the way, can you hear me? Clear? Clear ba?
Yes, sir. Clear na, sir.
How about my slides? Okay lang.
Yes, sir.
Okay,
Clear. Yep.
so we are now on section 3 of chapter 4. We have now the bivariate transformations. In our previous discussion, we have this method of finding the distribution of a function of a random variable. So now we're going to extend that for the case when we have a bivariate random vectors. So we let this vector of random variables x, y with a known probability distribution, and now consider a new bivariate random vector with random variables u and v, in which we define u to be equal to g sub 1 of xy, and then v is equal to g sub 2 of xy, where g sub 2, or rather where g sub 1 of xy and g sub 2 of xy are some specified functions. If we have a b in a subset of the Cartesian plane, and then these the values of this vector of u v, an element of this subset b, if and only if we have the value of this vector xy is also an element of a, where a here it is the set of all xy. This is actually an element of r square, such that this ordered pair g sub 1 xy and g sub 2 xy is an element of b. Thus, the probability of this random vector u v, an element of b, will just be equal to the probability that the random vector xy is an element of a. In other words, the probability distribution of this random vector with random variables u v is completely determined by the probability distribution of this random vector with random variables xy. So to start, let me elaborate this paragraph. Say we have here our sample space S, and this is our set of real number. We know that a random variable is a function from the sample space S to the set of real number, but this time we're going to consider a bivariate random vector. So it's a function from the sample space S to R, and we have here our function now denoted by this random vector with random variable xy. So if we have an outcome w here in our sample space S, then it has an image in R, which is actually x of w and then the y of w. So it's an element of the r square pala to ngayon, r square, a Cartesian plane, xy plane, and then usually we take the value of x here to be small x, and then the value of our random variable y here is the small y. Okay, yan ang ginagamit natin na mga values for x and y. And then we have a functions g sub 1 and g sub 2. Okay, again this is r square, and then we have here the two functions g sub 1, and then we have g sub 2. So the random vector now, which is with random variables u and v, is a function from the sample space to r square. Ito ngayon. This is now our random vector uv. So the image here in our uh, r square would be g sub 1 of x of small w, and then we have here g sub 2 y, sorry, g sub 2 y of w. And we denote this now by small letter u. Small letter u, and this one would be small letter v. Okay, so in other words, this ordered pair of random variables u and v is the same as g sub 1 of this random variable xy, parang ganun lang yan, and then we have here g sub 2 of this random variable xy. So if we have a subset b of r square here, ito, meron siyang subset. This is a subset of r square. And then here, we have also a subset of r square. So this A, as being defined, it is the set of all xy. Take note, it is the set of all xy such that the g sub 1 of xy and then the g sub 2 of xy should be an element of B here in R square. Okay, this A here is being defined. It is the set of all ordered pair xy. Kaya ito yung x natin, no? Is xy. It's a set of all ordered pair xy such that we have here the g sub 1 of xy and then the g sub 2 of xy here. This ordered pair is an element of B. And then usually we denote here by small letter u and this one by small letter v. Hence, the probability that the random vector u be an element of the subset B will be just equal to the probability of the random vector xy, which is an element of A. In other words, the probability distribution of UB is completely determined by the probability distribution of X and Y. Okay, so kaya nilagyan ko dyan ng space dyan just to elaborate more the first paragraph. So if the random vector xy is a discrete bivariate random vector, then there is only a countable set of values for which the joint PMF of this random vector is positive. And we denote it by script A. So in other words, our script A here, yung script A natin ngayon, this is the set of all ordered pair xy such that the joint, yung joint PMF of the random variable xy here is positive. That is our script A. And then we define a script B here be the set of all ordered pair UV. Kaya itong nakita natin ngayon dito, no? UV, UV, Pero in this case, we'll use script B here such that U will be equal to G sub 1 of xy, and then V will be equal to G sub 2 of xy. That is for some xy in script A. Take note, this is for some xy in script A. Then script B is a countable set of possible values for our discrete random vector uv. And then for any uv in script B, if we define this AUV as the set of all xy, which is an element of script A, such that G sub 1 of xy is equal to U and G sub 2 of xy is equal to B. This time, this is for all, no? This is for all xy now in the subset AUV. So in this case, this script A contain this set AUV. AUV. Okay, so the joint PMF of this random vector UV defined by this can now be computed from the joint PMF of our random vector XY. And we have here our formula 4.3.1. This is the joint PMF of U and V. It can also be expressed in this manner, or it can also be expressed in this form. Okay, the probability that xy is an element of this set AUV. So this is all, no, for all xy now in AUV. It will be equal to this countable summation of the joint probability mass function of x and y, okay, where the ordered pair xy is an element of this set A sub UV. Let me give you an example to illustrate this concept. By the way, I modify the problem in the book. I have this for my modification. The distribution of the sum of the Poisson variables. Say we let x and y be independent Poisson random variables with parameters theta and lambda respectively. And then we define u here to be a function of these random variables x and y. And that is the sum of these two random variables x and y. And then v here is a function of y. Pwede lang naman, no? Function of y. And then first question here, find the joint distribution of x and y. I think this is very easy because we have two independent Poisson random variables. So for letter A problem, solution of that is for letter A, the joints we have here. The joint PMF will just be equal to the product of the marginal PMF of x and y. So we have here. I hope you can identify random variable and the realized value. Kagaya nito, this is a random variable y. Ang realized value niya, small y. Ito, big X and then small x. Ang ganun. And then the PDF for the Poisson distribution, we have for a parameter theta sa x, we have here theta to the x e to the negative theta over x factorial. That's for the random variable x. Then we have here lambda to the y, e to the negative lambda, and then y factorial. And then we have the values for our x, 0, 1, and so on and so forth. And then y, 0, 1, and so on and so forth. Okay, so that's the answer for letter A. For letter B, find the joint distribution of U and V. Take note, we can now find the joint distribution of U and V from the joint distribution of X and Y using the formula in equation 4.3.1. But before that, we're going to establish our sets. Okay? For our sets. Our script A here, we know that it's the set of all ordered pair X, Y, such that the value of X here, we know 0, 1, so on and so forth. Y here, 0, 1, so on and so forth. And then uh, the joint PMF should be positive. We That's given, no? And then we define our uh, function g sub 1 of xy. Yung g sub 1 of xy natin, that's actually equal to capital letter U. So it's a function of x and y. It's the sum x plus y. And then g sub 2 of xy, pwede naman yan, no? V will just be equal to the random variable y. So that is, we can have this in terms of their realized value or values. So yung u natin, that is g sub 1 of, say, xy. So this is now equal to x plus y. And then we have here g sub 2 of xy here. This is simply equal to a y. Yung g sub 1 of xy is actually a realized value of u. So pwede natin yung small u na lang. So we have x plus y. And then this one is small v equal to y. Okay, if you notice in our two equations here that u is equal to x plus y, and then v is equal to y, this would imply that our u here is greater than or equal to v. Okay, you can have this argument since y here is equal to v, and then our x, itong x value starts from 0, 1, and so on and so forth. And also, if we have now for any ordered pair, we have an ordered pair uv, element of script b. Okay, element of script b. Yung alam natin yung script b here is the set of ordered pair uv such that u is equal to g sub 1 of xy, v is equal to g sub 2 of xy. So for any uv in script b, we now define our a sub uv. That's for any uv. So this is now set of all ordered pair xy. That is an element in our script A that's based on what we have discussed a while ago. Hindi na siya for some, no? Kaya to for all na to. That's for any, no? That's for any. And then we have here the g sub 1 of xy will be equal to u, and then the g sub 2 of xy will be equal to v. Or it could be set of all xy such that our y here is equal to v, and then our x will be equal to u minus v. So isa lang yung possible values ng xy. No, for any xy, so the y will be equal to v, and the x will be equal to u and v. So it is just the set containing only one, ordered pair. And that ordered pair now, we have u minus v, and then we have v. So using the uh, the equation that we have, ano yun? 4.3.1, uh, the joint PMF of U and V, it should be the summation, countable summation of this joint PMF of XY. Then we have here XY, such that this XY is an element of AUV. Eh, isa lang naman yung element natin dyan sa ating set na AUV, which is just the ordered pair U minus V and then V. So, yung summation, isa lang. So, simply, we can express this as f of xy. That our x here, we have here U minus V, and then V for y. So, we can now use it can be now, as I've said, we can use the uh, probability distribution of the random vector xy. Gagamitin natin yun, itong gagamitin natin. So we just replace x there by u minus v and replace y by v. So we have now theta to the x, so theta to the u minus v, and then e to the negative u minus v over u minus v factorial, and then the other one, we have lambda to the v, e to the negative lambda, and then we have here v factorial. So the v here would be equal to 0, 1, and so on and so forth. But our v here, rather our u, would start from v, and then v plus 1, and so on and so forth. Kasi dito, pwede naman na ma-express natin dito, no? So our u here will be equal to v plus x. So x from 0, 1, 2, and so on and so forth. And for v, add that. Okay, so that is our joint probability mass function for u and v. Ano yung letter C problem? Find the marginal distribution of v. And then for letter D, find the marginal distribution of u. So for letter C, question, the marginal distribution of v, since we know that v is equal to y, so clearly v has a Poisson distribution with parameter lambda. What about for the marginal distribution of u, where u is x plus y? Okay. Diba? So notes that for any fixed non-negative integer u, our joints, pwede na nalagyan dyan, our joint PMF is positive only for v 0, 1 up to u. Okay, since u is equal to v plus since we know that our u is greater than or equal to v, so v would be from 0, 1 up to u. Thus, if we're going to compute now for the marginal PMF of u, we have now, from our definition, we have here the countable summation of the joint PMF, okay, u, v, and then the summation is for all possible values of v here. And since u is greater than v, we have v from 0 up to u. So the summation will start from v from 0 up to u. And that is for all u here, 0, 1, and so on and so forth. Okay, so we're going to substitute our joint PMF of u and v now. We have here theta to the u minus v, e to the negative u minus v over u minus v factorial. Then we have lambda to the v, e to the negative lambda. Then we have here v factorial. Again, u value from 0, 1, and so on and so forth. And then if we're going to remove, or we can write the factors that does not depend on v here before the summation symbol, we can verify this. We have here e to the negative theta plus lambda. Okay. Sorry. Mali pala tayo na. This is e theta to the u, then e to the negative theta. Wala rapod mo ni tingog dahil sa ko, no? This negative theta. Ito, negative lambda, u minus v. So, kani siya, pareha ni lambda. So, kani, erase ni siya. Wala na ako nabantayan. So, minus lambda. So, we have that. Then, we have here the summation. Countable summation. We have theta to the u minus v. And then we have lambda to the v over u minus v. Okay, sorry for that. U minus v factorial, v factorial. So v from 0 to u. And then again, the u value, that's for all, no? Gamitin natin yan. Okay, so to simplify this further, we have e to the negative theta plus lambda. Okay, we have here the summation v to the u. Then we have here u factorial. Pwede natin dito, this expression u factorial does not depend on the index of our summation. So pwede natin lagay dito u factorial. And then we have u minus v factorial, and then we have v factorial. Then we have here lambda v theta u minus v. Then u is equal to 0, 1, and so on and so forth. Notice na itong expression na to, you can see that in the binomial theorem. Diba? Sa binomial theorem, we have that. So we have now e to the negative theta plus lambda over u factorial. And this expression is equal to lambda plus theta raised to u. Parang sabihin natin itong x plus y raised to n. This is equal to the summation of n choose I. Then we have here x to the I. Then we have y to the n minus I from 0 up to n. And then, pwede naman yan. Going to take this n factorial. Then we have here n minus I factorial. Then we have I factorial. X to the I and y to the n minus I. Okay, halos pareho na to. Ito at saka ito. Okay, so ano ini-imply nito? If you're going to look at our formula now, anong distribution ang U ngayon? Therefore, U has a? It has a?
Poisson.
Yep, Poisson distribution. With parameter?
Theta plus lambda, sir.
Okay, theta plus lambda. Theta plus lambda, that's correct. That's our U. Okay, so in our example here, we're going to define our script A based on our discussion. And after that, you're going to define your set A sub UV, because that would be the set A sub UV will be the basis of the ordered pair XY in our summation. In this case, the A sub UV has only one element, and that is the ordered pair AUV for the first component, and the second component is V. So the countable sum of our joint PMF of XY will just be the PMF of XY on the ordered pair U minus V and then V here. Ito. Okay, then we can now solve for our joint PMF of the random variable or of the random vector with random variables UV. And then we can also compute the marginal PMF given that we have found already the joint PMF of U and V. Okay, so any questions or clarifications for that? Any questions? We considered only for this example a discrete bivariate random vector. So let's proceed now. Parang walang question yata eh. Naintindihan ba lahat ng diniscuss ko? Okay, so theorem 4.3.2. This is for the generalization of what we have solved. If X has a Poisson distribution with parameter with mean theta, and then Y has a Poisson distribution with mean lambda, and then X and Y are independent, then the sum will have the Poisson distribution with mean theta plus lambda. Let's go now to the continuous case. So if X and Y is a continuous random vector with a joint PDF, then the joint PDF of our random vector UV can be expressed in terms of this joint PDF of XY. Okay, so we let our script A as the set of all ordered pairs such that the joint PDF is still positive. And then we let script B here. Ito yung script B natin. This is a set of all ordered pair UV such that U is equal to G sub 1 of XY, and then V is G sub 2 of XY for sum. Okay, kaya ito for sum. xy in script A. That's why we need to determine this set as script A sub UV. Pero in the discrete case, so the joint PDF UV will be positive on the set script B. Okay, so we let u here to be equal to g sub 1 of xy, and then we let v be equal to g sub 2 of xy, and it defines a one-to-one transformation of script A onto B. So kung one-to-one transformation from script A onto B, that would be for all, no? xy na dahil na diyan, because it's a one-to-one transformation from script A onto script B. When we say onto, that means that for each ordered pair UV in script B, then there is only one XY in script A, such that the ordered pair UV will just be equal to the ordered pair G sub 1 of XY and then G sub 2 of XY. And then for a one-to-one transformation, we know that if G sub 1, or say for two functions to be, we have a one-to-one, if f sub 1, say if f sub 1, if f, for one-to-one, say the u, g sub 1 of xy, and then v for g sub 2 of xy, then we have only one. In a simple expression, if we have a if f sub 1 of if f of x1 is equal to f of x2, we can show that x1 is equal to x2. Okay, so we have a one-to-one transformation from script A onto script B. And then if we have a one-to-one transformation from script A onto script B, then we can find the inverse transformation. We can let x here be equal to h sub 1 of uv, and then y to be equal to h sub 2 of uv. And then in the univariate case, we have actually the derivative. We have the derivative. At this time, in the bivariate case, we have the partial derivatives. So we have here the determinant of our the determinant of the matrix of partial derivatives. We name it as the Jacobian of our transformation. So for a bivariate case, we have here our J, the Jacobian of our transformation. That's the determinant of this the matrix of the partial derivatives, in which in the first row we have the partial derivative of x with respect to u, and then we have the partial derivative of x with respect to v, and the second row we have the partial derivative of y with respect to u, and then partial derivative of y with respect to v. Taking now this the determinant of a 2 by 2 matrix, so we have this difference, the product, this product minus this product. Okay, since we know that x is a function, we denote it as the h sub 1 of uv, and then y we denote it as a function of uv also, h sub 2 of uv. Hence we can find these partial derivatives. Okay, so the joint PDF now of uv is 0 outside the set of script B, and then on the set script B, we have here the joint PDF. So the joint PDF of uv is equal to, okay, we have here the joint PDF of xy, and this time evaluated on x. We know that x here is a function of u and v because it's the inverse. of our function g sub 1. So we have h sub 1 of uv and then h sub 2 of uv times this, not the determinant, but it's the absolute value of the Jacobian of our transformation. Okay, uh, let's have an example for this continuous case. The distribution of the product of beta variables. Let x has a beta, alpha, beta distribution. Y has a beta, alpha plus beta, and then gamma distribution be independent random variables. Then the joint of xy is this. It's very clear. Okay, independent. So it's the product of their marginal. We have f of x. Okay. So if x has a beta, alpha, beta distribution, so we have here the gamma of alpha plus beta, gamma of alpha, beta, x to the alpha minus 1, and then 1 minus x beta minus 1 for the value of x between 0 and 1. And then for y has a beta alpha plus beta and then gamma distribution, then ito yung kanyang probability density function on the values of y between 0 and 1 exclusive. Okay, so let x here yan be given, and when we define now as again this example in the book, I modify it in such a way that we're going to find these following distributions. So letter A, find the joint distribution of x and y. Nakuha na natin yan. Letter B, find the joint distribution of u and v. Find the marginal distribution of v, and then find the marginal distribution of u. We define u here to be the product xy, and then v to be equal to x. Okay, so this is our transformation now. U is equal to the product xy, v is equal to x, and so the set of possible values for v, since x here, no, x is equal to v, and v has an x has a beta distribution, so the possible values of v would be between 0 and 1 exclusive. Then for a fixed value of v, okay, for a fixed value of v, say the image will be small v, then u must be between 0 and v. Since we know that x is equal to v, and that is v, and then y is between 0 and 1. Okay, notes. We're going to define now our sets. So yung script A natin, we have the set of ordered pair xy such that the joint PDF is positive, right? This time, pwede naman yan, no? The x and y yan, comma, is between 0 and 1. And then we define our script B here to be the set of all ordered pair u and v such that the u is equal to g sub 1 of xy. It's a function of x and y, and that is equal to the product xy. And then our v here simply equal to x. Take note, this is for some xy in script A. And then the values of u here, ayan, less than 1. So we know that u is a value between 0 and v. That is why we have here u is greater than 0, but it is less than v, and then it is less than 1. And this time we're going to take the partial derivatives. Okay. yung partial derivatives natin. Okay, we have here the, oops. What do we have? The partial derivative of x with respect to u. Okay, so that's actually equal to uh, uh, so, bago muna to, express muna natin yung ating so transformation natin. Now we have u equals to xy, and then v is equal to x, if and only if. We're going to determine uh, the inverse. So we have now u over, so yung x muna natin dito equals sa v. So y is equal to u over x, so u over v. And then we can now compute for the make or the partial derivatives. The derivative of x with respect to u is clear from here is equal to 0. The partial derivative of x with respect to v, the answer is equal to 1. Partial derivative of y with respect to u, the answer is equal to 1 over v. And then the partial derivative of y with respect to v, okay, the answer is negative u over v squared. So this implies now that the Jacobian of our transformation, we have j, which is actually the determinant of these partial derivatives. We have 0, 1, we have 1 over v, and then negative u over v squared. So the answer for this is equal to the negative 0 man lang. 0 pa muna. 0 minus 1 over v. So we have negative 1 over v. Okay, thus to compute for our joint PDF of u and v, we have using our formula, we have the joint PDF of x and y. This time for x, yung x natin dyan, equals sa v, yung y, and then the absolute value of our Jacobian of our transformation. And then u here is greater than 0 but less than v, less than 1. Okay, so using the above, yung joint natin, by the way, di pa natin pala na-simplify ito. Pwede naman ito mag-cancel, itong part na to. This one, then that one. Okay? So ang result niyan will just be equal to gamma of alpha plus beta, gamma of alpha. So we have here gamma of alpha, gamma of beta, gamma of gamma, small gamma. Okay? So we have here x to the alpha minus 1, 1 minus x to the beta minus 1. Then we have here y to the alpha plus beta minus 1, and then 1 minus y. We just simplify our joint PDF of x and y. So, and then Guys, can you hear the parang kan? Meron kayong naririnig na parang movie sounds?
Linear answer, wala. Linear answer.
Okay, so we have that. So we're going to use this joint PDF. Excuse me for a while. Okay, so to determine the joint PDF of U and V, we simply replace this X here, no? And then we simply replace X here by V, and then we oh, what's happened? Okay, and then our uh,
What? Or is mustache one?
Y by U minus V. So, sulat lang natin dito ngayon. We have now gamma of alpha plus beta plus small gamma here. Sulat naman, no? Gamma of alpha, gamma of beta, gamma of alpha. And then we have x man yun kanina. So we have now v to the alpha minus 1, then 1 minus v to the beta minus 1. Ah, yep, beta minus 1. And then we have y. Yung y natin ngayon is u over v. So u over v, alpha plus beta minus 1, and then we have also 1 minus u over v, and this is equal to raised to gamma minus 1, then times 1. Okay, the absolute value of the Jacobian of our transformation, we have positive 1 over v. Ito yung sa last part. Then we have here. Okay, so simplify. Anong nangyayari dito? The more if you're going to simplify that, itong part na to, say for example, this one, this is a v alpha over v. Okay, and then this u of alpha, and then we have here u of beta minus 1. Sa part na yan. So meron tayong v of alpha, then v of beta minus 1. So ito mag-cancel. Simplify. Yung para ma-simplify natin yan.
Where is your cell phone
Copy.
again?
So,
But then, where is your cell phone?
this will be equal now to gamma of alpha plus beta plus small gamma. So gamma of alpha, gamma of beta, gamma of alpha here. So we have here, can simplify now. By the way, pwede tayo mag-add dito, no? Say, you multiply this by u over u. Pwede naman yan. Dito lang na. Erase ko na lang. So dito pwede tayong mag-multiply dyan. U over here. That's why we have this result now. U of alpha minus 1. Ito, tsaka ito. And then we have this. 1 minus V. Algebra lang naman to. Over V raised to beta minus 1. Then we have 1 minus UV to the gamma minus 1. And then we have U over V squared. V squared. Okay, so hence we obtained our joint distribution, probability density function of U and V. Ayan, ano yung simplification natin ngayon. Parang mali itong pagkasulat ko V pala to. Nandun pa rin. Alpha minus 1. Okay, so next. It's already time. Okay, I'm going to continue this next meeting. We have already computed for the joint PDF. The joint PDF of X and Y. We have also computed for the joint PDF of U and V. So next meeting, by Monday, we're going to compute the marginal PDF of U and V. And then I'm going to give you another example for a continuous case. A continuous case, that would be the sum and difference of normal variables. And then after that, some normal variables. Okay, so we have this theorem. Mayroong space dyan para sa computation. And then the last theorem will be for section 3, theorem 4.3.5. I've been using this, okay, but we have this proof in theorem 4.3.5, in which if we have random variables x and y that are independent functions of these random variables x and a function of y also, these two functions are also independent. Yung section 4, hierarchical models and mixture distribution, I gave you this already as a reading assignment. So I'm going to proceed in our next meeting in section 5, the covariance and correlation. Then after chapter 5, we're going to extend it into the multivariate case. So instead of having a random vector having two random variables, then we're going to extend it into 3 or more random variables. But we're going to consider the theorem that will be used if we have a multivariate case. Okay, so that's all for this afternoon. I think before we go, do you have any questions or clarifications? Yung discussion natin una, bivariate, no? Transformation. For the discrete case and then for the continuous case. Yun lang yung na-discuss natin ngayon hapon. Any clarifications or questions? By the way, konti lang present ngayon. Yung advantage naman, may recording, and that is why you can listen to our discussion anytime na you are free. So, none so far?
I think wala na, sir.
Okay, so that's all for this afternoon. Have a nice weekend, and class dismiss.
Thank you, sir. Salamat.
Okay, bye.
Sir. Salamat, sir. Thank you. Bye.
I'm going to end now the recording.